Hey guys, so I'm back to talk about more limiting reactants. Migraine day, what can I do? So, the idea behind limiting reactants, as I've gotten up on the board here, is it's the reactant that holds you back. So, as I was doing the example before I changed clothes on a different day, was when we showed the s'mores, it's 2 graham crackers, 1 marshmallow, 1 piece of chocolate, 1 s'more. So as long as you stay with that 2-1-1 ratio, you're fine. 4 graham crackers, 2 marshmallows, 2 pieces of chocolate, 2 s'mores. 6 graham crackers, 3 marshmallows, 3 pieces of chocolate, 3 s'mores. 8, 4, 4, 4. What happened to me? So I had 8 graham crackers, 8 marshmallows, 3 pieces of chocolate. So when that happened, poopers, you only got 3 s'mores. Doesn't matter that I had extra of the other stuff. If there's not one more piece of chocolate to make the rest of that sweet sandwich, you're out of luck. And so that means this disappears and you're going to have some marshmallow and graham cracker left over. That's what it means by a limiting reagent. And the graham cracker and marshmallows are extra. They're excess. You could look at it as excess reagent, depending on which side of the fence you sit on. So that's what we're doing. So it's kind of the same idea here, that instead of just doing it with full pieces, you can also do that when you've actually got grams of the stuff. So I'm going to step through this a couple of different ways and show it to you with the math. And then I'm going to do it a couple of different problem-solving ways. And this way is a little bit harder to see at first, at least with the example I gave you with s'mores. So what happens if you did this with, instead of looking at it as whole graham crackers, but you had grams of graham cracker, grams of marshmallow, and grams of chocolate. Well, if you look at it as a chemical reaction, which we can't do, let me just highlight these here for a second. So here are your molecular masses of your s'mores and your chocolate and your marshmallows and your graham crackers, okay? And so if you have in the problem 31 grams of graham cracker, how much s'mores could you make in grams? Well, what were the steps that you go through? And this is just like what we were doing before when we were assuming we could just make as much as we wanted, 100%. 31 grams of graham cracker. Well, you have to go into moles of graham cracker, look at your chemical reaction and say, okay, this many moles of graham cracker will give me this many moles of s'mores, and then use my molecular mass to convert my grams of s'mores back into moles. 3 steps. So 31 grams of graham cracker. Well, 1 mole of graham cracker has a mass of 7.75 grams. 1 mole of s'more, I was doofus, 2 moles of graham cracker. So because you need 2 graham crackers to make 1 s'more, and then 32.5 grams. The s'more is 1 mole of s'mores. So when you punch this in your calculator, 31 times 32 is going to be divided by 7.75 times 2. That gives you 65 grams of s'mores that could be made. Oh, that winds out being 2 s'mores. Doubled the recipe. Makes sense. Okay. Now, we've done that for our first ingredient. What happens when we move on to ingredient B and we have 11 moles of marshmallow? Okay, so we made 65 grams of s'more. Let's change this a little bit here. Well, what happens? Well, we have 11 grams of marshmallow. Well, 1 mole of marshmallow weighs 5.5 grams. Okay. So we need to switch that part. We also need to switch this ratio. 1 mole of s'more comes from 1 mole of marshmallows. Okay. Well, that's not too big of a fix. Okay. But the last conversion stays the same. That hasn't changed at all. That's still the same step because we're in moles of s'mores. We just need to convert it to grams. Oh, okay. Well, when you do that part of it, it's not so crazy. So let me make sure I'm right. I was in grams of marshmallows, converted into moles, switched my moles of marshmallows into moles of s'mores, and then went back down. Okay, that should be good. So 11 times 32.5 divided by 5.5, that also gives me 65 grams of s'mores. Ah, that was same as the last answer I just had. Those give me the same amounts. Doesn't seem like those are holding me back. Let's check this one. So we already know what's going to have to change here. So let's change our fractions a little bit. So I've got 17.25 grams of chocolate. Okay, well, 11.5 grams of chocolate is 1 mole of chocolate, according to my recipe. Okay? Well, this ratio stays the same here. I want to get out of moles of chocolate into moles of s'more, and then out of moles of s'mores into grams of s'more. So let me double check my math one more time. I'm in grams of chocolate, converted out of grams of chocolate into moles of chocolate. Okay, so I'm good so far. Convert out of moles of chocolate into moles of s'mores, and then out of moles of s'mores into grams. I'm good. So if I multiply 17.25 by 32.5 and divide that by 11.5, that should give me grams of s'mores, and it does. And it's 48.75. Aha! Chocolate is my limiting reagent. You can still figure it out from grams. Oh, that's actually not all that complicated. I just wish there were an easier way to go through so I didn't have to do my math 3 times through and do 3 equations. There is. You just need to be willing to identify it. So another video coming up, we're going to have to do a couple of these. Get comfortable with identifying your limiting reagent, and all you have to do is be able to compare moles. It's easy to do when it's 1 to 1, a little bit harder if it's 1 to 2, 1 to 3. It's a lot harder when you get more complicated equations, but you can still do it. All right, sit tight. We'll be back.